for our bill work. So it says, so we got two lines, and the equation for a line is y equals mx plus b, but we're using a. So a is the slope. So let's talk about the slope first. What do we notice about the slope? What's one thing that you can tell me about the slope of this graph?
Positive.
It's positive. Good. Let's write that down. We know A, which is our slope, is positive. All right, what about the slope of this equation?
Negative.
All right. Because when we're looking at it, I like to look at it as a hill. It's a straight line. So if I were to draw a person here, this person is going up a hill, so it is a positive slope. But for my second one, this person is going downhill, so A, which is your slope, is negative. All right, so somebody else. Now let's talk about B. And B is your y-intercept. So now let's talk about the y-intercept. So somebody else tell me, what's something that you can tell me about the y-intercept? Now for this first one, this is where my y-intercept is. So Chris, what's something you could tell me about the y-intercept? Well, all y-intercepts cross the y-axis. So that is true. But what's something else a little bit more specific that you can say? Kenna? That it's a negative number. How do we know that the y-intercept is negative? Because it's below the x-axis. So what we can say about B, which is our y-intercept, we can say that that is negative. And for the second scenario, right here, do you think that number is a positive number or a negative number? It's a positive number. So B is positive. So you should be able to look at a line and determine if the slope is positive or negative, and if the y-intercept is positive or negative. So that's something that we should be able to do from looking at a graph. All right, let's go ahead and take out our review books. We got a couple of examples. We're going to work on homework together. And then at the end of class, you'll have a chance to look at your Module 3 test and make corrections. So let's go ahead and go to page 215. Okay, so we have some definitions on page 215. A polynomial in one variable. Okay. A polynomial in one variable. Couple of things that we need to keep in mind when we're looking, in order for us to determine if it's a polynomial, is that you cannot have negative exponents. So for it to be a polynomial in one variable, we can have no negative exponents. I'm going to add that to the side. So no negative exponents. And that's what this is saying. It's just sometimes the definitions they give us are really mathy. N is a non-negative integer. That just means no negative exponents. So I'm trying to give you another way to interpret the definitions. The terms are written from the highest exponent down to the lowest. Now, we talked about this yesterday, but the degree is the what? How do you find your degree? The highest exponent. Good job. So, and that's still the same for today. It's your highest exponent. That highest exponent is really important. And the leading coefficient is always going to be that number in front. So this paragraph just talks about some other ways to describe different degrees, and I also have it written on the board. If it's a quadratic function has a highest exponent of 2. That's a second degree. A cubic function, that's a third degree. Those are the most popular functions. But we can also have a quartic function. A quartic function is a 4th degree. So quartic is 4th. And a quintic is 5. So let's take a moment and we have 2 examples to do today. So let's first look at example 3. And see if you can tell me, for this first one, what is your degree and what is the leading coefficient of this function here? Okay, so what is the degree? 4. Good, because that's our highest exponent. And our leading coefficient is 2. So this is an even function with a positive leading coefficient. So even though it didn't ask us, but who remembers from yesterday, what does that mean about the arrows? They're going to go in the same direction. Would they go up or down? Up. Good job. All right, what about question B? What's your degree?
3.
Degree is 3. And what about my leading coefficient? What would that be? 7. Okay, so on this graph for part B, what is this graph going to do on the right? I know it's not asking us that, but I want us to, because we're gonna get good grades on this next test. We got 2 more tests. We gotta do well on them. What does that mean for the right side of this graph? Is it gonna go up or down? Oh, let me ask again. On the right side, raise your hand if you think it's gonna go up. Raise your hand if you think it's gonna go down. All right, it will go up. So on the right side, because this 7 is positive, it is going to go up. And what is it going to do on the left? Is it going to go up or down? Down. It's going to do the opposite. Okay, this is an example. Because see how we have x being multiplied, we have 2 variables being multiplied together. Whenever you see that, this is not a polynomial of 1 variable. Okay, so this does not have a degree or a leading coefficient. We actually see that in our homework, and we're going to do that together in a minute. All right, our last question, what about D? What would be my degree? 5. So your degree is 5. Now this is the tricky question. What about the leading coefficient? It's a 1. There's an invisible 1. It's not 0. Okay, leading coefficient can't be 0. So when you don't see a number in the front, that means that it is 1. All right, so let's go ahead and pause for a second. Let's go to our homework. Take out your homework. I want to look at 7, 9, and 11. Go into our homework. These questions, do you see in your book how it says example 3 right above number 7? So what that means is that example we just did, that's going to explain how to do 7, 9, and 11. I think it's 7, 9, and 11 that we have to do in this section. All right, so let's look at 7. N plus 8. What is the degree? Your degree is your highest exponent. And when you don't see an exponent, the exponent is 1. So there's an invisible 1 attached to that n. So your degree is 1. That's your degree. Now your leading coefficient is the number in front of n. And that is also 1. So the answer to number 7, your degree is 1 and your leading coefficient is 1. Go ahead and try to do number 9 by yourself. So what did you say for number 9? What is your degree? 5. So your degree is 5. And then what about your leading coefficient? -5. All right, number 11. Is this a polynomial in one variable? No. Because do you notice how we have 2 variables being multiplied? Okay, so this doesn't have a degree. So you would say this is not a polynomial in one variable. 11 is not a one variable polynomial. All right, so now let's go back to our reveal book and let's look at example 5. So we also had a question similar to this in the homework. I'm not in the homework, I'm sorry, on the last test, where you had a graph and you had to tell me the zeros. The zeros, does anyone remember what another word for zeros? Solutions, roots, one more. X-intercepts. When you're looking at a graph, your x-intercepts will determine how many zeros you have, how many real zeros. So a real 0 is determined by your x-intercepts. So this graph in particular how many times does it cross the x-axis? I'm actually I want you to put a point there. So it crosses here, here, and here. So how many times did it cross? 3. So there are 3 real zeros. And we emphasize real because there could be imaginary solutions, but we're focusing on your real zeros. So now let's go back to your homework. And I want you to look at numbers 15 through 20. So you should have over half of this homework already done. Looking at numbers 15 through 20. The only thing you have to tell me is how many real zeros each one has. Looking at the graph, how many times does each one cross through the x-axis? So let's look at 15 and 16 together. So looking on page 220, look at number 15. Show me with your finger what the answer is. How many real zeros? I only see 1 because it's the x-axis, not the y-axis. It's only the x-axis. So let me go ahead and redraw that graph. That graph looks something like this. Your real zero, this is your x-axis, is only here. Your y-axis is not a 0. So the answer to number 15 is 1. What about number 16? Show me with your fingers. How many solutions for number 16? Oof. 4. Good job. There's 4. All right, go ahead and do the rest through 20. And then when I call your name, you can see your test, and then you can also use this time to work on corrections. If you would like to take the Module 3 test, it has to be done before the end of next week. So spend this time. Our phones should not be out. Let's not have out our phones. I need for you all to dial in because we only have 2 more tests. And I think we only have like 6 weeks left. 3 weeks, and then we go to Thanksgiving, and then we come back. We have like 3 weeks. So it's really over. So I'm really trying to help you all, especially those who are really, really close. Pull your grade up so you can get your credit. So focus on 15 through 20. When I call your name, you can see your test, and we can work on our corrections for the last 20 minutes of class.